Introduction. Read introduction there.
In this lab, we will be using U.S. mint pennies to measure the relative amount of an isotope in an unknown sample. After remaining largely unchanged since the first release in 1909, the mass of the Lincoln penny lost a full 20% in 1982. The change was a money-saving measure. Less expensive and lower density zinc was substituted for some of the original copper. Copper prices had risen so much that copper on a penny was worth more than 1 cent. The pre-1982 pennies were 95% copper and 5% zinc. Current pennies are 97.6% zinc, which is coated with a thin layer of copper.
Okay, so you go into your algebra class and you always kind of ask the question, does this really work? I mean, we're learning it, but we never put it into practice. So you kind of guess, is this really useful? So today you're going to determine if that is true. Algebra really does work. So we're going to measure some pennies, the mass that is. If you have an 82 penny, it weighs around 3 grams. If you have one that's younger than that, older, like 81 and beyond, older like 1950, they all weigh around 3 grams. We call those the pre-82. The post are the ones that come after 82, like 2017. They weigh around 2.5 grams because they're coated in copper. They have a zinc base. This is your algebraic problem. It's x times the mass of the pre plus 10 minus x times the mass of the post. That's on your paper. I've put it up here to show you that's what we're doing. Yes, they do. The ones that are made now do it faster. The ones in 1982 were made of complete copper, so those last longer. They're made of zinc coated in copper, so they corrode faster. They wear down faster because they're cheaper, yeah. Okay, so here is your example. This is your total mass of 10 pennies, and then you're going to solve for x. Now, when you solve for x, x equals around 0.59. Do the math. If you're having trouble and you don't get 0.59, come to me and I'll help you. You're going to take a container like this, and you're going to place it on the balance. Empty container. And you're going to measure the mass. And you're going to record that on the data table. Now, I don't have containers up here with 10 pennies in them. You're just going to count 10 pennies out. Why do we keep it in the container? So they don't fall over your desk. I didn't count the pennies out because people move them around and it's hard to be for sure that, you know, people don't trade them out. So we're going to go on the honor system. The whole point is, does algebra work? So when you calculate this and it shows you have zero pre pennies, open the container up, count them out. See if you see a pre one there. Then randomly do 10 more. I'd like for you to do it 3 times just to see if you can determine whether algebra works. That's the goal of this assignment. Determine the isotopes. Any questions? Down. That's the isotope. You got to start 100 gram, end 6.25 gram. They want to know how long it will take for that to occur. You have a half-life of 33 seconds. So you're solving for the elapsed time t. So you're going to take... Alex, write this down. So log 6.25 divided by 100 divided by log 0.5. Nice job, Rain. Close. Anybody else? Get your calculator out. Try to solve this. You want to put in log parentheses 6.25 divided by 100 parentheses. Hit enter. And then log, divided by log parentheses 0.5 parentheses. And you should get 4. Check that.
Hold up, so this one's a pre one, ain't it?
It looks like a post. What's it say on there? says
Wait, so these are all the same?
2014. So it should be like
What, you seen it
2.5.
on there?
Pretty cool, man. Pre-penny weighs 3 grams, Y, and your post one weighs 2.48 grams. Anybody know why? Vance? Why does the pre-penny weigh 3 grams and the post-penny weigh 2.5 grams? I don't know. Well, there's something called copper. So prior to 1982, all pennies were made with pure copper. However, copper is expensive. It's worth more than a penny. So if you're making a penny and it costs more than a penny to make, people might start stealing them. So they use what's called copper plating. They have a zinc center and wrapped in copper today. That's how pennies are made. That's why they weigh less. Up here, if you didn't know that, now you do. So when you weigh that, you're going to record the data up here as the example is shown. The post, 2.48, the pre, 3.0. And then you're going to take your container right here and you're going to place it on a balance, as you see, without the pennies. And you're going to record the mass of the container. Then you're going to count out 10 pennies. Place it in the container, weigh the mass of the 10 pennies, right? And that goes right here, total mass of 10 pennies. Now, why are we putting them in the container? So you won't look at them. We're going kind of on the honor system to see if the math works out. So you're going to solve for x here. We solved this earlier today, and it solves for around 0.59. So this first container didn't have any pennies in it that were pre. They were all post pennies. We did it again and it solved for 4. So I want you to do this 3 times a day to see if you can get the right number correct. So once you solve for 0 pennies, open it up and see if you find any. If you find one, then the math was wrong. Is everybody clear? So try that. Arsenic 81. You have a start of 100 and end of 6.25. They want to know the time that is elapsed if the half-life is 33 seconds. Anybody solve that for us? Now, you're going to need a calculator to do this. In the calculator, you want to hit the log button, parenthesis, 6.25 divided by log 100. Drill. We have an earthquake drill today. Earthquake drill. These are the earthquake drill positions. Good job. Excellent. Positron emission yesterday. We do not know what initiates a positron emission.
So what do they do to fix it? The solution is positron decay.
Can you read that for us, Cody?
How long does it take?
Garrett, go ahead.
Okay, how long does it take? I don't know that number. I mean, I do, but I don't want to read it. 100 true grams. 100 gram sample of AS 81 to decay to 6.25 grams.
Okay, can anybody come up here and do that for us? So for the first problem, we are using the formula for half-life to solve for the elapsed time, as you can see on the board. So the objective now is to solve for t. Anybody do that with your calculator?
I guess the code of the first sequence your container is the number.
It's really weird already. I'm just gonna
pennies.
Atoms that do positron decay have this problem. In their nucleus, they have too many protons and not enough neutrons. So what do they do to fix it? The solution is positron decay. One protons that's in the nucleus of this unhappy atom turns into a neutron. This solves the problem. Now we have fewer protons and we have more neutrons.
Okay, now typically over an arrow like that, you don't put turns into, you put some type of catalyst. So we don't, if you're just putting turns into, we're not really clear about what it's doing. Now we do know that the reason is that there are too many protons and not enough neutrons. But we don't know what's initiating this, what's causing it. If there's a problem, yeah, but then there's got to be some initiation. Maybe you'll figure that out. I gave you are a little bit different than what we're going to do because I don't have duct tape on this to keep you from looking at what the pennies are, whether they're pre or posts. Now on the instructions it says get a sealed container with a number on it. So I didn't do that because people can pull the pennies out and they can get dropped and it's just a lot of confusion. What I want you to do is place this container on the balance. You write down the mass and then you're going to place 10 pennies in it. You'll count out 10 pennies. Now why are we putting it into the container? Because the container will hold them. So you've got it in there, and then you're going to go back to your desk and you're going to find the mass of the pennies. So you just subtract the two, the mass of the container from the pennies, as you see right here. Then you're going to solve for x. Ariel.
Just trying to grab a question.
Yes.
hole in your bag.
I know. I have the cup there to place them in.
I hate the smell of penny. I know, me too. I regret like that. I regret. Where are you going?
Right, and you get something around 25. This is telling you, when you do the math, that there are going to be no pennies in the container. But we still want you to open the container and look to see if you have any any pre-1982 pennies. So count it out to see if the math is correct. So the goal here is to show you that algebra works, that you can actually determine the pre and the post without even looking at them.
So what are we going to write it?
Well, we're going to, like I said, we're modifying it, and I give you that lab write-up sheet where you're going to show the modifications. I want you to do it 3 times. So you always turn in 2 sheets. You turn in this and your lab write-up sheet, which is right here.
So we do it with the cup and then without the cup?
You're going to use the cup to hold the 10 pennies. Now you can still, it says give you an average. You can still take 10 pennies that are pre and get your average, dividing it by 10. It's going to be close to 307 to 311. That's what I've noticed today. They're in that range.
So we take the math and just go.
Yeah, you're going to solve for x, right? So what's going to vary is this number, just a little bit, between 3.07. This could be like 2.5. So if you want to be detailed, that's great.
Yeah.
I support you.
Like my workman's Sonic.
It's amazing.
Well, there's a diamond there.
Oh my god.
Yeah, I know.
Oh, right.
Tamaya.
I didn't get it.
Isn't it 8.86?
No.
Brendan is going to tell us the answer. Please listen to Brendan. Or Brendan. 8.07 is correct. Now, what you want to do, Rachel, you want to...
Smells, I'm sorry. I just one spray, it smells like orange.
Get me afterwards. We're not confused.
Well, they are like the Indian pennies are worth like more than...
No, it was an accident.
Isotope is in an unknown sample. After remaining largely unchanged since the first release in 1909, the mass of the Lincoln penny lost a full 20% in 1982. The change was a money-saving measure, less expensive and lower density zinc was substituted for some of the original copper. Copper prices